Yes. Yeah, morning all. So in the last class, I was just briefing you about Azure Databricks, introduction to PySpark. Azure Databricks, right, developed by the creators of Apache Spark, provides automated cluster management with auto scaling feature compatible with all Azure storage, similar to IPython style notebooks, right, like Jupyter Notebook. Azure Databricks is a cloud service that lets you set up and use a cluster with Apache Spark installed with a driver worker architecture similar to local Hadoop cluster. What is Databricks? Provides a Spark cluster. It provides Spark cluster. It has got group of nodes, CPUs connected in a network. Group of nodes, CPUs connected in a network. We have two nodes, driver node and worker nodes. Driver node is the master node, worker node is the slave node. Spark is a very high speed processing execution mode for huge data. Right. Spark features in-memory computation, supports MPP, massive parallel process, distributed execution, right? Lazy evolution, persistence, partitioning, right? Yes, partitioning. Spark is 100 times faster than normal disk processing, right? So if you have got cluster, right, automatically if your data is increased by a huge amount automatically, it is going to scale, auto scaling feature. And whenever that work is done, again, it will come back to this original cluster size. Who is providing this? Databricks. Databricks provides Spark cluster. And today, but this Databricks, this general Databricks, right? It's not compatible with all the Azure storage services. So Microsoft and Databricks collaboratively launched a new product called Azure Databricks. Azure Databricks provides a Spark cluster with auto scaling feature compatible with all the Azure storage services. In Databricks, who is processing the data? Spark is processing. Spark multi-language support. Spark can be coded with Scala, Python, Java, and R language. ADB is a developer-friendly environment. It's a developer-friendly environment. So PySpark is a Python API to use Spark. It's an open source distributed cluster computing framework with in-memory computation features with parallel process style used for large-scale data processing, right? Yes. PySpark is the lightning fast technology that is designed for fast computation. Generally, PySpark is used for running distributed SQL, creating data pipelines, ingesting data into the database, running ML algorithms, working with graphs and data streams. Need for PySpark, large amount of data will be generated, right? So that data will contain some patterns, unknown corrections, market trends, customer preferences, other useful business information, right? We need to extract only the required data from that given data, right? So we require some more efficient tool to perform this kind of operations. So already we have got tools, but more efficient and flexible tools to crack this. Because of huge data, I want only the required data. So PySpark is such a kind. So combining Python and Spark would be the very efficient way for the world of this big data. So Apache Spark community came up with a tool called PySpark, Python API for using Spark.
So before starting this PySpark is we need uh, Python knowledge.
Yes, everything will be coding. See, one thing here I have given here. Sorry, not here. Spark can be coded with Spark is an execution model. Once again, Spark is not a language, it's an execution model. It can be coded with, it can be implemented, Spark can be implemented using Scala, Python, Java, or language. Any language can be used, but in the industry, mostly used ones are Scala and Python. Java and R language are never preferred in the industry. So Scala and Python are mostly. Previously, Scala was used a lot. Spark with Scala, we used to say, right? But in the 2016, 17, 18, 19, 20, for their Scala was used a lot. But today, like Python is mostly preferred. Means Spark implemented using Python language. Total implementation, your coding goes in Python. The Spark functionalities remain same in any language. Spark related functions, anything, all will be remaining same. But the coding, how you define a variable, how do you define a function, how you define a collection, that is going to be differed, right? For example, a very small example. For example, in Java, if you want to define a variable, int x equal to 10, you say int x equal to 10. That is in Java. In Scala, var x equal to 10, you will say var x equal to 10. Var or val, we use some keywords like var and val. In Python, just you will say x equal to 10. This way, you are going to differ, right? Programming to programming. Here int, here var, here no need of anything. Directly you say x equal to 10. So here Spark. So with the language, what we are using is Python. So PySpark, Python API. It's a Python API to use Spark. So Python API to use Spark. Okay. So total the Python coding implementation goes in Python. So it is the Python API to use Spark. It is an open source distributed cluster computing firm with parallel process style used for large scale data processing. Okay. If you see Spark was developed by Matai Zaharia. Matai Zaharia in AMP lab. In AMP lab, right? So it was open sourced. It was open sourced in the year 2010. It was open sourced in the year 2010. It was donated to Apache Software Foundation. It was donated to Apache Software Foundation in the year 2013. So this Spark was donated to Apache Software Foundation in the year 2013. PySpark features. First thing is in-memory computation. In-memory computation, right? Yes. Means storing and processing happening. Storing and processing. Storing and processing happening within the memory level, right? Within the memory level means RAM level. Storing and processing, not in the disk level, memory level. It is within the RAM. I said it is lazy evaluated. Lazy evaluated. Lazy evaluated. Lazy evaluated means on demand. On demand. Making the data flow to execute. On demand making the data flow to execute. Means on if you make it on demand only, you will execute whenever you make some action. By making an action. If no action, it won't execute. Fault tolerant. It has powerful fault tolerant model. It has got powerful fault tolerant model. It has got the capability of, for example, if any system goes down, right, it automatically has got the capability of getting the lost partitions. Yes. See, Spark data is going to be divided into multiple partitions. They are going to be distributed across multiple systems and are processed parallelly. That is what we call partitioning. Partitioning means if data is partitioned only, parallel processing can happen. For example, a labor example. If you got a task, if you got a job, a building construction, if you are dividing the job into multiple tasks, and if you are providing to multiple laborers, right, they are going to execute parallelly. Here also the same thing. If data are divided into multiple partitions and they are going to be stored across multiple systems and are processed by multiple systems parallelly. That's why very high speed. That too, the processing happening within the RAM level, storing within the RAM level and processing within the RAM level, right? Persistence. Persistence means making use of the output, making use of the output of already executed transformation. Already executed transformation, right? Making use of the output of already executed transformation. Partitioning means Spark data is divided into multiple partitions and are distributed across multiple worker nodes and are executed parallelly.
So this multiple worker nodes you are talking about, so these are automatically created or like how it's work?
So here you okay. Actually, we didn't discuss anything about the cluster. So here, cluster means group of nodes, CPUs connected in a network. We have two nodes, driver node and worker node. Master node and slave nodes, we say, right? Master and slave nodes, we say. Yes. See this. This entire thing we call it as a cluster. 40 node cluster or 60 node cluster, whatever the systems you got. So depends upon that. Cluster we say, group of nodes connected in a network. In that, the one we call it as driver node or master node. Node means what? CPU, system. Driver node or master node we say. This all we call it as worker nodes. Worker nodes. We call it as slave nodes. See, generally, if you talk about this Hadoop or Spark, there is a file, f1.txt file is there. f1.txt, in ADF, single partition, multiple partition, the concept is there. Partitioning. Have you heard about that in
Yes.
ADF, right? Partition. Okay, in that single partition, multiple partition. See here, single partition means the speed is less. The speed will be less. Multiple partitions, good performance. Why? Anyone can you say why?
And
Single
data
partition.
distributed in different tables.
See this f1.txt, if it is only one partition entire file, think that it is like a 4 GB file. 4 GB file. Only one partition. Means entire file taken as one partition. Means who should execute? Only system one. Only one system executing it. Think here worker one, system one, a system two, system three, system four. Four systems are there. This entire file executed or processed by a is processed by a single system. But if I'm dividing this f1.txt file into multiple partitions, 1, 2, 3, 4, whatever data, 4 GB data is there. 4 GB data, each GB, 1 GB in this, 1 GB in this, 1 GB in this, 1 GB in this. The data is distributed across multiple systems worker nodes and processed by multiple worker nodes parallelly. Which one I will, this will have higher speed, right? Means work done by 4 people, work done by single person, right? There will be a difference in that. But I got 40 systems out there. 40 systems, your data is distributed across 40 systems, 40 systems running parallelly, executing, right? The single file data. Work done by 40 people, work done by single person, right? Huge difference in the speed or not? Yes. Hello.
Yes. So, but here is question for 4 GB data, it's distributed by 1 GB, but how it's distributed? Like, is there any condition or is there any no extra column we need to create, or it's automatically distributed as per the uh, cycle?
So generally, right, file divided into blocks. Block size, by default, the block size is 128 MB. 128 MB blocks it is divided. Default, the block size is 128 MB. For example, in 4 GB, how many 128 MBs you are going to get? Think that some 30 blocks. Understand here? How this 4 GB is divided into how many blocks? 30 blocks. Understanding? Hello?
Yeah.
So this file always divided into blocks. Block size by default block size 128 MB. Means assume 4 GB means 30 blocks or assume 40 blocks, 30 blocks for it. 30 blocks will be stored across 30 systems. Right? Hello.
Yes.
So divided into fixed size blocks. Fixed size blocks. The data is divided into fixed size blocks, 128 MB blocks.
Mm-hmm.
And they are distributed across. For example, you may say, I doesn't have 40 systems. I have got only 2 systems. System 1, system 2. The system 1, 15 blocks are stored. In system 2, 15 blocks are stored. 15 blocks stored means executing each block is one task. Totally how many tasks here?
15.
15 tasks. Here how many tasks?
Same 15.
Means system 1 should execute 15 tasks. System. I am giving, for example, you are there and one more Y person is there. I am giving you 15 tasks for you and the other person 15 tasks. Can you execute all the 15 tasks parallelly? No, right? First,
Mm-hmm.
T1 task will be executed. Remaining 14 tasks will be in the waiting state. Understanding?
Right.
Here also T1 task executes, 14 tasks will be in the waiting state. Means just like your construction labor house construction, right? If 30 tasks given to 30 labors, they'll be executing parallel in 1 hour. But if you're giving the 30 tasks to 2 persons, what is the total time taken? 30 tasks given to 2 persons. 15 tasks to 115 tasks. 15 hours it takes minimum, right?
Right.
Means here within 1 hour, if more systems, right? More worker nodes. Systems means whenever I say systems means you say worker nodes or slave nodes we say. Understand here? Whenever we say cluster means one will be the driver or the master, remaining all will be the slave nodes. Whenever you go with offline, not with the cloud process, everything we will be designing it. We will be configuring all this. You will maintain like 60 systems. One will be the master, remaining all will be the slaves. In each and every system, we'll be installing Spark, Python, Java, all this will be installed. We'll be maintaining all this. But the same cluster in the cloud now, it is invisible to you. Just you will want how many nodes you want, worker nodes. I want 20 worker nodes. You will give 20. That's it. What driver node? What is the driver configuration you want? I want high configuration like RAM capacity, 64 GB RAM I want, or 16 GB RAM you want. 16 GB RAM if you are taking low charges, low charges will be applied. 64 GB, right? High charges will be applied. Even if you're taking 2 systems, okay, less charges. For every system, charges will be applied, right? For taking 60 systems. So in this way, in the cloud, as you are maintaining the cluster, so in the case of ADF, you cannot manage the cluster. You cannot configure or manage. Default cluster will be running. Whenever you say data flow debug, what is happening? Cluster is getting ready. Default cluster. You don't know how many worker nodes, everything. You cannot manage it.
Right.
The cluster won't be in your control in ADF. Understanding? In the initial first class of this data engineering, I said there is a concept of data flow in ADF. You no need to perform anything. AD data flow converts into every day. Who is executing this data flow? designed many data flows, right? In ADF. In ADF, many data flow activities. In that, without data flow debug, are you able to execute? Without data
No.
flow debug, you're not able to execute, right?
Yes.
Who is executing this data flow? Spark. Databricks. That is what is it? Databricks. In that Databricks, Spark is the what is that execution weapon. Observe, data flows are executed by data, that is Spark. And then, but have you written any Spark code in ADF?
No.
Have you written any Databricks of Spark code? No, no. Everything internally converted and executed by the Spark. Databricks cluster means Databricks, that cluster will be running. Spark cluster will be running. That's why whenever you say data flow debug, you have observed in the notifications or not. Whenever you say data flow debug, making the cluster ready, it will say. It takes some time for 5 minutes like that to
Yes.
make the cluster. You need to observe those things. Means cluster, it is running on the cluster, default cluster. Means, for example, I want high speed. I want high speed. I want high speed means what I should do? A building construction is there. The construction should happen very fast. Instead of 10 labors, make it 100 labors. Very fast it will go, right? Construction work. Instead of 10 labors, go with 10 times you increase. 10 times you increase means 100 labors. The building construction goes faster. In the same way, in this ADB with PySpark, right? Same way, if you want to achieve high speed, you need to increase more number of worker nodes. Understood, right? Anyway, see here, you cannot control the cluster in the case of ADF. In the case of cluster, you cannot see ADF, right? Okay, it's a zero coding ETL. As a beginner, you can go with ADF. You can everything you can drag and drop. It will be simple and easier, right? But for complex operations, complex queries, generally we go for ADB, Azure Databricks. That with so means there you can control the cluster. You can achieve more speed and complex operations where Spark can execute. You can write a Spark code. You can write especially for Spark code for non-structured, unstructured data, right? Graph data for graph data, unstructured data, graph data, streaming data, these kind of things, right? ADF cannot handle graph data, streaming data, data which keeps on incrementing, which keeps on generating, capturing the data, and even graph data, and writing ML, machine learning kinds of things. You know why Spark is preferring Python today? Python is the only language. Python is the mostly used language for implementing the
Yes.
machine learning, deep learning, right?
Yes.
Total data science implementation coding goes in Python, right? Can you see? Yeah. A total data science, that machine learning, deep learning, AI, everything, the language chosen is Python because Python has got many libraries, many modules for this, like NumPy, Pandas, Matplotlib, CP, Scikit-learn, TensorFlow. In this way, it is providing many libraries, modules for this data science environment, for this machine learning environment. Even Spark has got a library, Spark ML. Spark has got many things, right? Spark has made powerful MLlib library. Machine learning library is there. Spark streaming is there. Spark GraphX is there. Means Spark is also providing many functionalities towards this processing this machine MLlib, streaming, graph data, Spark SQL, all these things, right? So for this thing, especially for if Python is chosen, Python has already got a lot of modules, libraries for this machine learning. That's why, especially Spark has made Spark got powerful. Spark has got very powerful because of this libraries. Even Spark has got its own libraries, right? Many are available, many modules are available for it. And initially, when Spark was introduced, after Spark got introduced, right? Spark, Apache, Apache Spark, we say Apache Spark. Spark introduced by Apache. Understand this? Spark. Pankaj Chavan, did you attend yesterday's class?
No, sorry. Yesterday I didn't attend.
If you have attended, you won't ask that question, right? That's why I was asking. So, one second. What is ADB? What is data? What is Databricks? What is ADB? Yesterday, clearly I discussed. What is normal Databricks? What is the difference between normal Databricks and Azure Databricks? Databricks is not only for this Azure, also we have got for other things, right? So what is Azure Databricks and Databricks? Databricks providing Spark cluster. That Spark cluster, okay, provides Spark cluster with auto scaling. But that Databricks is not compatible with all the Azure storage services like Data Lake, Azure SQL, Cosmos. So Microsoft and Databricks combinedly, collaboratively launched a new product called Azure Databricks, ADB. So what it is going to provide? A Spark cluster. What it is going to provide? A Spark cluster. That too, whenever that huge data like TVs or petabytes of data or TVs of data, auto scaling means automatically it has to increase the worker nodes whenever required. Again, for example, if you're maintaining, I'm saying, okay, maintain 30 to 60. Whenever less load, okay, 30 nodes only to use. But whenever required, more data is coming, right? More data, it will increase to 60 or for up to 40 or 50 or how much required, it will auto scale. And again, once the work is done, again it will come back to 30. That is what auto scaling. Whenever more workers required, it will use it. Otherwise, it will go with the normal. Once the work is done, again it will come back to 30. That is auto scaling. And that too compatible with all the Azure storage services. That is what Azure Databricks. And in the Azure Databricks, who is executing? The execution happens by using Spark. Who is execute? Spark is going to execute. And Spark, in that Spark again, the language we are using is Python. That's why we say PySpark. Okay, fine. So here, after Spark, Apache introduced one more. Apache has introduced one more product, Flink. So from 2016, 17, 18, a lot of implementations went on Spark. If you're not using Python language, using Scala language. See, one more thing you need to understand, Spark built by using Scala language. Spark built by using Scala language. Scala is the native language of Spark, and Scala is used only for the Spark environment, no other environment using Scala language. So, okay, but later on, as I said, now Python is mostly preferred. But whenever Spark got introduced, when implementation going like 2016, 17, 18, people got updated with Spark immediately. It was hot cake in the market. But immediately, Apache introduced one more product called Flink, which was dominating Spark. And people thought that Spark is going away from the market and Flink is dominating it. Yes, Flink dominated Spark. In the Spark, up to Spark 1 version, 2 version, now 3 version is running. Spark 1.6 version, Flink was dominating. But when Spark 1.6 version was released, Spark has got powerful libraries, especially Spark was weaker initially in the initial versions of Spark. It was weaker. It was weaker with respect to data analytics. It was very weaker in aspects of data analytics, right? Especially like machine learning kinds of things or this graph algorithms for this. But immediately Spark introduced powerful libraries. It introduced powerful libraries, right, for ML, for graphs, and for the streaming, for all these things. Up to from Spark 1.6 onwards, Spark became equal to Flink. But when Spark 2 version was released, it again dominated Flink, and you cannot see Flink. Again, Spark 2 version onwards, Spark has got much more powerful libraries were introduced. It dominated Flink again. Now, okay, now the language which is chosen is Python. So we have got Spark with Python. So PySpark nothing but Spark plus Python. So both. So here I'll be discussing practically, right? So first I'll be discussing. So for this Spark, compulsory a cluster is required. A cluster, you know what is a cluster? Just now I said driver node, worker nodes will be there. Multiple worker nodes will be there. So here compulsory in who is providing the cluster? Who is providing it? Who is providing the cluster? For the Spark to execute for processing, very high speed processing technology, it requires a cluster compulsory. Who is providing the cluster? Hello? Who is providing the cluster? Databricks.
Azure services.
Azure Databricks. Azure Databricks is providing that, and that too with auto scaling feature and compatible with all this. So in the Azure, just like uh, just like ADF, just like ADF, how you got the instance for ADF, how you have created ADF instance. In the same way, for Azure Databricks also, you are going to create an instance. After creating the instance here, you are going to create a workspace. Workspace is where multiple users can communicate, interact with each other, like a data scientist, data engineer, all those things. After workspace creation, you are going to create a cluster. You are going to create a cluster. Cluster means where a driver node and multiple worker nodes. So here driver and worker nodes, right? And here cluster is of two types: single node cluster, multi-node cluster. Single node cluster, multi-node cluster. Multi-node cluster. Single node cluster means only, for example, I've got my system. In my system, I'm executing this. So my driver and the worker will be in the same. So both will be in the same thing. Multi-node cluster means multiple nodes will be involved. So for multi-node, the charges will be applied. Single node cluster, the charges will be less. So here in the multi-node cluster, you need to select the number of worker nodes you require. Number of worker nodes you require. and you can choose the configurations for your driver node and worker node. What is the configuration? High configurations you want, more charges will be applied. Less configurations. So for your practice purpose, right, go with single node cluster. Later, sometimes I'll be showing you on the multi-node cluster. Single node cluster you can go, and that too in this Spark. In this, we are working with PySpark SQL. PySpark SQL. If you are working with Spark related, right? If you are working with Spark related or PySpark SQL, right? See, you can work with this Azure Databricks. It will give 14 days trial. 14 days trial it is going to provide. Previously, you got 1 month trial, right? But this ADB is going to provide you with 14 days of trial. And that too, even the trial version, you won't see all the features. You're not going to see all the features of that entire features, even like Spark SQL kinds. For these things compulsory, you need to go with pay as you go. Or free trial will be there, standard version will be there, and premium version will be there. As compared with this will have less features. As compared to that, it will have some more features, but this will have all the full features. In this, you will see all the full features. Premium. Standard means you will be having all the features, but some features will be missing. This is basic one. Basic. That to 14 days trial only, right? Okay. For working with this, either you need to go with standard or premium for getting all these features, right? So that too, if you want, I will be saying during this course, I'll be saying you how you can minimize the cost. How you can minimize the cost, right? DBUs will be there, Databricks units, right? How you can minimize the cost or minimize the cost, where you need to stop and where which one you need to delete off. After your work is complete, you need to delete some of those things. Otherwise, today you have worked again after 2 days if you are working. So at the back end, it is going to take your space. It is going to occupy some space, those things. So this cluster, how to create this instance, how to create the workspace, Databricks workspace, how to create the cluster, and at the cluster, within the cluster, we are going to uh, have notebooks, right? Notebook means by default Python language. You're just like Jupyter notebook. If you have got knowledge on Jupyter notebook in Python, same way here notebooks will be there where we'll be writing the code, and that notebook will be attached to the cluster. If you have got even multiple clusters, to which cluster you are attaching that cluster, it will be attached. Yes. And you have got lot of utilities, Databricks utilities are there, right? That will be discussed. And so here, if you observe this in this here, creating Databricks workspace, adding users and groups to the workspace, creating a cluster, displaying clusters, managing cluster, starting a cluster, terminating cluster, deleting cluster, cluster information, cluster loss, cluster access control. Everything about the cluster management. And later, types of cluster. There are some different types of all-purpose cluster, job cluster. This is the all-purpose cluster. Physically, you will be creating. Job cluster you want to create, you doesn't have that create option. Automatically, whenever your job is running, your task is running, it gets enabled automatically, and automatically when the job is, it terminates automatically. That's everything I'll be discussing. Types of clusters. Later, using this PySpark processing Databricks utility, different types of utilities are there that we'll be discussing one by one. Databricks, how it is integrated with Blob, how it is integrated with Data Lake, Azure SQL database, right? And handling multiple formats like CSV, working with different file formats in this, and a processing, batch processing, right? Databricks batch processing. If you talk about this Spark or Hadoop or Spark, right? They are meant for batch processing, not for online processing. What do you mean by online processing and batch processing? Online processing means online applications or batch applications we say. Online applications means user interactive applications. User interactive applications. Here we are not developing any user interactive applications here. You're not developing any web applications here. Understand here, batch applications and online applications. Online applications, see, this Spark is not for online applications, for batch application. Batch applications means like a million. See, if we talk about online application, user interactive application. For example, you are making an online transaction. User compulsory should have interaction. It means user has to give the input. User has to give the input, right? For example, if you are making online transaction, source destination accounts, the inputs, everything you need to provide. You are making a single transaction. That is online transaction. But for batch, there won't be any interaction with the user. There won't be any interaction with the user. For example, batch means millions and trillions of things will be involved. Batch, millions and trillions of records or transactions. For example, credit card statements generation. All that millions and trillions of credit card statements then will be generated, where the user doesn't have any interactive. User won't interact. User doesn't give any input there. Automatically they'll be generated. That's kind of most of these financial applications, batch applications or batch. So you totally will be working with batch processing, batch applications, historical data load, incremental data load, date related, aggregation related, join related, everything by using PySpark. Okay, fine. So you can just some more introduction I'll be providing about this Spark. And tomorrow just I'll be showing you how we can create instance for Azure Databricks. Similarly, how you have created an instance for this ADF data lake in the same way for Azure Databricks you can create. But as I said, it will give 14 days of trial and workspace creation, cluster creation, notebooks creations, where you can create notebooks and the folders, where you can write the code and different types of utilities, right? And this different how to work with different handle file formats and this batch processing, right? Fine. Try to be regular to the sessions and try to interact with the sessions. You can ask queries during the sessions. Fine. Okay. So we'll continue from tomorrow and tomorrow you'll be getting a new link, right? Yes. Tomorrow you'll be getting a new link. That new and tomorrow I won't be available. So tomorrow there won't be any session. Day after tomorrow we'll be attending. Day after tomorrow you'll be getting a new link, right? Check with that. Still people who didn't enroll for Databricks can enroll and get the link to your mail IDs. Check your mail IDs. You'll be getting a new link for day after tomorrow's class. From day after tomorrow, we'll be just going with the things. We are going to start with the things. If anyone not enrolled for this, because there are only people, there are some people who have enrolled only for ADF, right? So still, if you have not enrolled for ADB, we can just enable, let's enroll for this ADB for getting the link, right? ADB, you know already Databricks with PySpark especially has got a great demand in the market with huge packages. People who know PySpark have got a great salary packages, right? So fine. You'll be a separate WhatsApp group will be created for this Databricks, right? For the interactions, right? Right. Day after tomorrow. So I'm stopping for now. Yes, we'll continue. Thank you. Yes. Yeah. Morning, all. So before I start, can one please confirm whether my voice is clear, whether the screen is visible or not? Yes. Yeah. Can anyone please confirm whether my voice is clear, whether the screen is visible, right? Yes.
Yes, yes.
Yes, sir. Yes, sir. It is clean. It is clear, sir.
Fine. Thank you. So Azure Databricks with PySpark. Okay. What is Databricks? What is Azure Databricks? What is Databricks? What is Azure Databricks? Why Azure Databricks? Why Azure Databricks? And coming to this Spark, what is Apache Spark? Why PySpark? Spark with Python implementation we see here. Why PySpark? Need for PySpark. Need for PySpark. Features of PySpark. Next, job market. ADB with PySpark. So this is what I'll be discussing, right? What is Databricks? What is Azure Databricks, right? What is Databricks? What is Azure Databricks? Why Azure Databricks? What is Apache Spark? Why PySpark? Need for PySpark. Need for PySpark. Features of PySpark and job market of ADB with PySpark. Okay. What is Azure Databricks? What is Azure Databricks? See, Azure Databricks developed by the creators, developed by the creators of Apache Spark, provides provides automated provides automated cluster management, automated cluster management with auto scaling feature, but with auto scaling feature. Whenever required, it can increase. Whenever required, it is going to be decreased. Comes to this norm, and also it is compatible with all Azure storages. Compatible with all Azure storage. And this these are similar to IPython, IPython styled notebooks. Okay. Azure Databricks. Azure Databricks is a cloud service. I can say it's a cloud service that lets set up and use setup that lets you set up and use a cluster and set up a cluster with Apache Spark with Apache Spark installed with Apache Spark installed with driver worker driver worker architecture with the driver worker architecture, right? Yes, otherwise master slave architecture or driver worker architecture. Similar to local Hadoop or local Hadoop cluster. Yes. It's a cloud service that lets you set up and use a cluster with Apache Spark installed with a driver worker or master slave architecture, similar to local Hadoop cluster, right? Yes. So generally, previously, okay, before this Azure Databricks, we had got normal Databricks. What is Databricks? First, what is Databricks? What is normal Databricks? Just it provides a Spark cluster. It provides a Spark cluster. It is going to provide Spark cluster. What is a cluster? Group of nodes. Group of nodes. Nodes means CPUs, I can say. Group of CPUs connected in a network. Connected in a network. We have two nodes. We have two nodes. Driver node, that we say master node. And secondly, worker nodes. Worker nodes. We say like slave nodes. And provides a Spark cluster. You may ask, Spark. What is Spark? It is a very high speed processing execution model. It is a very high speed processing execution model for huge data, or big data. Mainly if you see the Spark features, mainly like in-memory computation. First thing is like in-memory computation. In-memory computation means processing, storing and processing happens within the memory level, RAM level, right? And secondly, like supports MPP, supports MPP, massive parallel process. What is it? Massive parallel process. Distributed execution. Distributed execution. And I said massive parallel process. And it's, see, the data is going to be divided into multiple partitions stored across multiple systems and processed parallelly. And also it is lazy evaluated. Lazy evaluated. Lazy evolution. Lazy evolution. Active evolution. Lazy evolution means active means then and there, whenever defined or declared, immediately executing. But lazy evolution, until you make some action, it won't get executed. Just like a normal functions, programming functions, right? If we define a function, until you make a call, it's not going to get executed. So whenever you want, how many times you want, you are going to call it. In the same way, lazy evaluated, whenever you make an action only, the entire data flow is going to get executed. Until then, it won't execute. And you've got like persistence. Persistence means you can also execute already executed transformations. You can execute already, you make use of already executed transformation output. And also like partitioning. Partitions means the data is going to be divided into multiple partitions. And as more number of partitions stored across more number of systems and more number of systems parallelly processing it, right? So here Spark is 100 times faster, 100 times faster than normal normal disk processing, right? It's 100 times faster than normal disk processing. For example, assume a cluster. Assume a cluster of 100 nodes. These 100 nodes can process, this 100 nodes can process 2 TB of data, 2 DB of data at a time. At a time. For example, assume your data volume increased. Your data volume has increased by a huge amount. Assume your data volume has increased. If same cluster is used, speed goes down, right? As data is increased, and if the same cluster is used, speed goes down. So to have high speed, again the solution. To have high speed, the solution is scaling up the cluster. So to have high speed, again we need to scaling up the cluster. Adding some 100 new nodes. Adding 100 new nodes. After 1 month, again adding 100 nodes. Again adding 100 nodes. As data is keep on increasing and keep on adding the nodes. 1 month again adding 100 nodes. So every time scaling up. The physical data center. Every time scaling up the physical data center is a complex task. So the solution. Same cluster in the cloud. and the two with auto scaling feature. The two with auto scaling feature. Auto scaling feature, right? Who is providing this? Who is providing this? Databricks. So same cluster in the cloud, that too with auto scaling feature. Who is providing it? Databricks. So what is that? Databricks provides Spark cluster, with auto scaling, feature. Example. Today, your organization data load requires 200 nodes. Tomorrow, for example, tomorrow data volume increased. Assume tomorrow data volume increased. It has to be extended. It has to be extended to 200 automatically. It has to be extended 200 automatically. And again, and after processing is done, it has to revert back to 100 nodes. Today your organization data load requires 200. Tomorrow your data volume increase, it has to be extended to 200 after processing is done, again it has to revert back to 100 nodes. This is general Databricks. This is whatever I discussed. This is general Databricks. Yes. This general Databricks is not compatible, right, with all the Azure services. The two Azure storage services, I can say. Storage services. What are the Azure storage services? Azure storage services are right, like Azure Data Lake, Azure SQL, Azure Cosmos DB. Yes. So that's why Microsoft plus Databricks collaboratively launched a new product, Azure Databricks. So that's why Microsoft plus Databricks collaborative launched a new product called Azure Databricks. So what are the things you see? Azure Databricks. provides a Spark cluster, provides a Spark cluster with auto scaling feature, and compatible, right? Yes. All the Azure storage services. In Databricks, who is processing the data? Who is processing the data? Spark, right? In Databricks, who is processing the data? Spark. Spark. It is a multi-language support. Multi-language support. That is, Spark can be coded with Scala. It's a default. By default, Spark built using Scala language. Today, mostly like Python is preferred. Spark with Python, like PySpark, we say, right? And Java, it can be also be coded with Java or R language. It can be also be coded with R language. Spark can be coded with Scala, Python, Java, or language. And ADB, Azure Databricks, right, is a developer-friendly environment. One second. Apache Spark. If we talk about like Apache Spark, right, yes, or why PySpark is required. Open source. Say I can say PySpark, right, is the Python API. Python API to use Spark. The Python API to use Spark. It is an open source, distributed, cluster computing, framework with in-memory computing feature, with in-memory computing feature, with parallel processor style, open source, distributed, cluster computing framework with in-memory computing feature, and with parallel process style, used for large scale data processing, You can say PySpark is the lightning fast technology. I can say it is a lightning fast technology that is designed for fast computation. It is a lightning fast technology that is designed for fast computation. It's a very demanding tool among the data engineers to work with bigger data sets. So PySpark used for here you are going to see for run PySpark is used for running distributed SQL. It is used for running distributed SQL, creating a creating data pipelines, ingesting data into database, for running ML algorithms, working with graphs and data streams. Right. Just a second. Yeah, sorry, I'm suffering with cold. Sorry. PySpark used with running distributed SQL, creating data pipeline, ingesting data into database, running ML algorithms, working with graphs and data streams. So if I talk, what is the necessity for this or need for PySpark? Need for PySpark, right? Yes. Large amount of data is getting generated, right? Day by day. This data contains some hidden patterns, unknown corrections, market trends, customer preferences, and useful business informations. It is necessary to extract all this valuable informations from the raw data. So we require some tools to perform these different types of operations that do on the huge data, that is big data. So we have already got some tools to perform these tasks on these data sets, but the tools are not that much efficient. So we need some scalable and flexible tools to crack this big data and gain benefit from it. So PySpark is such a kind. So combining Python and Spark, combining Python and Spark is the very efficient for the world of big data. So Apache Spark community came up with a tool called PySpark, that is Python API for using Spark. Yes. I already discussed, right? The PySpark features, right, in memory computations. So storage and processing happening within the memory level, lazy evaluated. On demand, we are going to execute the flow. And we have got some other like powerful fault tolerant model, even during the execution, during processing as the data is distributed and data is processed by multiple systems. If any system fails, right? So it has got the capability of redeveloping the lost partitions. And it's partitioning, already I said the persistence feature, right? And generally, where it is used, real life usage of this PySpark, right? So in commercial sector, right? Like real-time processing, like banks and other financial systems using this PySpark to retrieve this customer social media profile. And also in the credit risk assessment and also in fraud detections, right? And also in healthcare, in analyzing or predicting the patients who are going to face the issue. Even in the entertainment industry, like the most popular OTT platform like Netflix using this PySpark for real-time processing for web series, and also processing nearly 450 billion events per day, right? And also in e-commerce, this like Flipkart, Amazon, all this they are using this Spark, right, for advertising, right, and provide some enhanced customer experience, right, right. Even many other websites like using this Spark for advertising, for kind of recommendations, these things, right? Yes, fine. So this, especially this PySpark, I said it can be implemented in multiple languages. Mostly like Spark with Python and Spark with Scala are mostly used in the market currently. Previously, Spark with Scala was used a lot in the year 2016, 17, 18, 19. These years, like the Spark with Scala was mostly used, but currently, right, Spark with Python implementation is used, right? Spark with Python. Fine. So there is a great demand for this PySpark. You can see if ADB with the PySpark. So you can see it's a very hot cake in the market. Even you can see the packages, salary packages for it. You can see huge packages for it, even 1.5 times more than the other technologies. The same way, they'll be expecting that skills, technical skills from your side. So if you see the course content, what I'm going to discuss, right? So everything will be in brief, in depth. I'll be discussing about all. So before this, I'll be giving some. I'll be just briefing an overview about this big data Hadoop and Spark. Yes, just check this course content, right? Sorry. Azure Databricks. So introduction to big data, introduction to this Hadoop, introduction to this Spark. Before I go with this introductions to this Azure and creating Azure Databricks service. So creating Databricks workspace is important, right? Where Databricks workspace where everyone can communicate, right? Multiple users can interact with each other. So and Databricks service with Azure CLI command line interface, right? Adding users and groups to the workspace, creating a cluster from the user interface, getting started with notebooks and jobs, creating and configuring clusters, managing clusters, displaying clusters, starting cluster, terminating a cluster, deleting a cluster, cluster information, use cluster logs, cluster access control, types of clusters, all-purpose cluster, job clusters, Databricks pools, Databricks without pools, Databricks cluster mode, standard, high concurrency, single node, auto scaling, Databricks runtime versions, multi-user clusters, Databricks utilities, credential utility, data utility, file system utility, job utility, library utility, notebook utility, secrets, widgets, Databricks integration with the blob storage, with Azure SQL database, with Synapse and Snowflake, Databricks handling different types of file formats, CSV, JSON, Parquet, Excel, XML data, ORC file format, and data batch processing, right? Historical data load, incremental data load, data transformations, so creation of data frames here, and different data frames functionalities I'll be discussing here. What are the different data frame functions and historical data load, incremental data load, data transformations, related functionalities, join operations, window functions, union operations, right? And for streaming API, what is streaming process? Streaming with PySpark API, handling bad records, loading the data into tables, Databricks Lakehouse, difference between data lake and Delta Lake, introduction to Delta Lake, features of Delta Lake, how to create Delta Lake, how to DML operations in Delta Lake, merge statements, handling SCD type 1 and type 2, handling data deduplications in Delta Lakes, Delta tables, handling streaming data in Delta Lake, workflows in Databricks, introduction to workflows, create, run, and manage Databricks jobs, schedule Databricks jobs, and monitor Databricks jobs. So everything I'll be discussing in brief with multiple examples, working examples. All right, Databricks with PySpark. Right. How to create a cluster, everything you'll be discussing here. We're creating a Databricks service, Databricks workspace, and creation of cluster, and how to, and working with the notebooks, and how to attach the notebooks to the cluster, working with these different notebooks, working with different jobs. If you got any queries, you can go with your queries, right? So from tomorrow, I'll be starting with the things, right? This introduction to this Azure Databricks. So I was saying about normal Databricks. So it provides Spark cluster, but it's not compatible with all the Azure storage services. But Azure Databricks, so what is that? Microsoft and about this both Databricks, Microsoft and Databricks collaboratively, they launched a new product called Azure Databricks, which provides Spark cluster with auto scaling facility and also compatible with all the Azure storage services. Okay. If we talk about this, so whatever this cluster, whatever the cluster, right? Management, cluster management, everything will be in our hand. But in the case of ADF, it won't be in our hand. Azure Data Factory, the cluster won't be in our hand. You will get the default cluster there. Doesn't have that configuration options there. But here you will be having all that pieces where you can, how much you want the cluster capacity, everything you can configure. Okay, fine. So just it's an introductory session of this Azure Databricks and PySpark. So tomorrow I'll be starting with the things, right? Same time at 9 o'clock. Is you can follow the same link for tomorrow. Any other queries from your side? Yes. Okay. So I'm stopping for now. We'll continue tomorrow. More discussion on this. Fine. Thank you all for your time. Yes. Yes. Yeah, morning all. So in the last class, I was just briefing you about Azure Databricks, introduction to PySpark. Azure Databricks, right, developed by the creators of Apache Spark, provides automated cluster management with auto scaling feature compatible with all Azure storage, similar to IPython style notebooks, right, like Jupyter Notebook. Azure Databricks is a cloud service that lets you set up and use a cluster with Apache Spark installed with a driver worker architecture similar to local Hadoop cluster. What is Databricks? Provides a Spark cluster. It provides Spark cluster. It has got a group of nodes, CPUs connected in a network. Group of nodes, CPUs connected in a network. We have two nodes, driver node and worker nodes. Driver node is the master node, worker node is the slave node. Spark is a very high speed processing execution mode for huge data, right? Spark features in-memory computation, supports MPP, massive parallel process, distributed execution, right? Lazy evolution, persistence, partitioning, right? Yes, partitioning. Spark is 100 times faster than normal disk processing, right? So if you have got cluster, right, automatically if your data is increased by a huge amount automatically, it is going to scale, auto scaling feature. And whenever that work is done, again, it will come back to this original cluster size. Who is providing this? Databricks. Databricks provides Spark cluster. And today, but this Databricks, this general Databricks, right? It's not compatible with all the Azure storage services. So Microsoft and Databricks collaboratively launched a new product called Azure Databricks. Azure Databricks provides a Spark cluster. with auto scaling feature, compatible with all the Azure storage services. In Databricks, who is processing the data? Spark is processing. Spark multi-language support. Spark can be coded with Scala, Python, Java, and R language. ADB is a developer-friendly environment. It's a developer-friendly environment. So PySpark is a Python API to use Spark. It's an open source distributed cluster computing framework with in-memory computation features with parallel process style used for large-scale data processing. Right? Yes. PySpark is the lightning fast technology that is designed for fast computation. Generally, PySpark is used for running distributed SQL, creating data pipelines, ingesting data into the database, running ML algorithms, working with graphs and data streams. Need for PySpark, large amount of data will be generated, right? So that data will contain like some patterns, unknown corrections, market trends, customer preferences, other useful business information, right? We need to extract only the required data from that given data, right? So we require some more efficient tool to perform this kind of operations. So already we have got tools, but more efficient and flexible tools to crack this. Because of huge data, I want only the required data. So PySpark is such a kind. So combining Python and Spark would be the very efficient way for the world of this big data. So Apache Spark community came up with a tool called PySpark, Python API for using Spark.
So before starting this PySpark, is we need Python knowledge.
Yes, everything will be coding. See, one thing here I have given here. Sorry, not here. Spark can be coded with Spark is an execution model. Once again, Spark is not a language, it's an execution model. It can be coded with, it can be implemented, Spark can be implemented using Scala, Python, Java, or language. Any language can be used, but in the industry, mostly used ones are Scala and Python. Java and R language are never preferred in the industry. So Scala and Python are mostly, previously Scala was used a lot. Spark with Scala, we used to say, right? But in the 2016, 17, 18, 19, 20, there Scala was used a lot. But today, like Python is mostly preferred. Means Spark implemented using Python language. Total implementation, your coding goes in Python. The Spark functionalities remain same in any language. Spark related functions, anything, all will be remaining same. But the coding, how you define a variable, how do you define a function, how you define a collection, that is going to be differed, right? For example, a very small example. For example, in Java, if you want to define a variable, int x equal to 10, you say int x equal to 10. That is in Java. In Scala, var x equal to 10, you will say. Var x equal to 10. Var or val, we use some keywords like var and val. In Python, just you will say x equal to 10. This way, you are going to differ, right? Programming to programming. Here int, here var, here no need of anything. Directly you say x equal to 10. So here Spark, so with the language what we are using is Python. So PySpark, Python API, it's a Python API to use Spark. So Python API to use Spark. Okay. So total the Python coding implementation goes in Python. So it is the Python API to use Spark. It is an open source distributed cluster computing firm with parallel process style used for large scale data processing. Okay. If you see Spark was developed by Matai Zaharia. Matai Zaharia in AMP lab. In AMP lab, right? So it was open sourced. It was open sourced in the year 2010. It was open sourced in the year 2010. It was donated to Apache Software Foundation. It was donated to Apache Software Foundation.